Thank you, Tom. Alive, Brad? Got it? Ohio gozaimasu. Good morning from Japan. I need a volunteer before we get started. I need a cup of water. Somebody get a cup of water for me. Just set it there on the pulpit. This is hard work for me to do a lot of talking. I don't do a lot of it.
Don't let him fool you.
How is everybody this morning?
Great.
Want to have some fun while the pastor's away? You want to go for a ride? I'm going to take you for a ride. I'm going to take you all the way from Fukushima, Daiichi, Japan to the cross. That's a stretch. It takes an engineer to do it. This is an aerial photo of two plants. This is Fukushima Daiichi units 1, 2, 3, 4, and this is Fukushima Daini. Most of the news was about Daiichi to the left. They especially had problems with this one, Unit 1. As you recall, on March 11th, Japan was hit with a severe earthquake. It was unprecedented. It was the strongest earthquake, I think, that they had had in over 100 years. However, the plant actually survived the earthquake. Thank you very much, Carol. It was the tsunami that got them. Just to give you an idea of how strong that earthquake was, on the Richter scale of 7.9 to 8.5, no structures remain standing. Bridges are destroyed, fissures in ground, pipes break, landslides, rails bent. On the Richter scale 8.5 to 9.1, and 9.1 is as high as the scale goes, it says, damage total. Waves are seen on the ground surface. So you could practically see the ground bouncing and you can see ripples in the ground. Lines of sight and level distorted. That would be kind of like when you're burning brush or you see a forest fire and you look through the air, you can kind of see the heat waves, you know. It distorts the vision. Can you imagine that? Having an earthquake that severe that it's distorting your line of sight. That's amazing. And get this, at that level of an earthquake, objects are being thrown up into the air. They experienced a 9.0 Richter scale earthquake, and bear in mind that this is a logarithmic scale, so magnitude 9.0 is 10 times stronger than 8.0. And the strongest I think we've had around here in this area was that one we had in December, not this last December, but December 2009. I was in our house, and all of a sudden I heard this rumble. What in the world? Was this a low-flying supersonic military aircraft or what? I couldn't get over how loud it was. And that was only, what, 3 point something? Not very high. But Michael was one of the first to recognize it was an earthquake. He was here telling everybody, you know, hey, it's an earthquake. What happened? It just...
There's a button you push there.
All right. I just hit the right arrow. Well, I'd like to talk to you a little bit about designs. We're surrounded by designs. There are designs everywhere. You look at this pulpit, and you would not say that pulpit just happened. Somebody designed that. Somebody can do woodwork. Somebody carved that. When we put out the communion table, we have wood trays to hold the little cups. Troy designed and made the cover, the wood cover, with the little cross on it. It didn't just happen. We look at buildings, and we don't just say, oh, Isn't it neat how that building just happened? No, it didn't just happen. It was designed by someone. We look all around the world and we see design. We see evidence of a designer. So I'd like to talk to you a little bit about designs, good designs and some not so good, and then some that are flawless. There were some design weaknesses at Fukushima Daiichi. This plant is very similar to Cooper Nuclear Station. It's a General Electric design boiling water reactor, Mark I. However, Unit 1 is an older one. It's a BWR3, not a 4 like we are. And it began commercial operation in 1971, about 3.5 years before we did at Cooper. It did not have some of the design improvements and the modifications that the later plants have, including us, and that hurt them a little bit. Notice, if you will, the ocean, of course, and that a seawall they have. And notice that the plant is not all that high above the water. That's significant. In this, I'd like you to notice these white tanks. Those are diesel fuel storage tanks for the emergency diesel generators for emergency power in the event you lose all off-site power. Well, they built the seawall about 6.5 meters tall, and the tsunami was at least 7 meters tall. And this was not just a little wave of water. The entire ocean raised up and was coming at them, and a giant wall of water crashed over their seawall, and it hit their buildings, and it hit the diesel fuel storage tanks. However, they survived the earthquake. All the control rods inserted. The reactor was scrammed. Fission was shut down. The reactor was put in a safe condition. The only thing they had left to deal with was decay heat removal, and that became a little bit of an issue for them. The emergency diesel generator started after they lost all off-site power. They ran properly as designed. However, their AC switchgear was in the basement of the turbine building. That was not a real good design. The water poured into the basement of the turbine building, submerged their AC switchgear and the diesel generators. And it did one more bad thing. It absolutely smashed the diesel fuel storage tanks. That's what's left of a diesel fuel storage tank. It just crushed it, ruptured it. So now they were in a pickle because they had no long-term supply of diesel fuel to run the diesel generators. The diesel generators are flooded, they're underwater. The AC switchgear is underwater. Now the plant is down to one thing, batteries. Well, the batteries are only designed to last about 8 hours, as Chu knows. DC power only, so after 8 hours, they're in blackout. That's some Japanese news. Luke, are you here? Can you read that? No? Luke has been taking Japanese lessons, and he taught me how to say good morning in Japanese, so I owe everything to Luke. Thank you, Luke. I don't know what that says. Probably not good news. One of the design improvements we have at Cooper is called a torus hard pipe vent. In the event that the fuel rods get hot enough to undergo a chemical reaction, they produce hydrogen. We have the ability to vent primary containment through a hard pipe vent to our elevated release point, basically a stack. They did not have that option here. The only place they had to vent hydrogen was to the refill floor of the reactor building, which they did. They followed their procedures, and unfortunately there must have been an ignition source somewhere, and they had a little hydrogen deflagration and lost the sheet metal off the sides and then the roof of the reactor building. It did not destroy the main concrete and steel structure, though. And the news media didn't tell you that primary containment remained intact and the reactor remained intact. It was just structural damage on there. They also did not have